Good morning. Today we are going to discuss entity relationship model. What is the need for having an entity relationship model? Actually, in a relational database management system, every data or the DBMS contains a number of tables and data is stored in the form of tables. Okay. So, if you want to have a good database designer or a system designer, that means if you want to computerize a particular firm or enterprise, initially what you have to do is you should have a discussion with the stakeholders. You should have a discussion with the stakeholders, and depending on through interviews, through questionnaires, and through interaction, you are going to conduct a thorough understanding of what is happening there, and we will come up with this entity relationship model. And once you have an entity relationship model, that means if you have a problem, for example, suppose that your firm is having a number of employees and they are working in some departments and they are working on some projects. So all these things are interrelated. So in your firm, a number of entities are there. In your firm, a number of entities. For example, if you are considering your college, then students form an entity, teachers or faculty form another entity, then administrative, that means the office there are administrative staff, they forms another entity, they will form another entity, then classes are entities, rooms are entities. So generally speaking, mostly nouns are entities. Nouns, for example, rooms, classes, the building, students, teachers, administrative staff, all these are entities, and a number of relationship exists between the students and all the stakeholders. That means uh, in a very big enterprise like college, you have a number of entities. You can identify a number of entities and their interconnections. That means there are communication or there are relationship exists between all these entities, and the graphical representation of that is called an ER model or ER diagram. The graphical representation of that is ER diagram, and once you have a very good entity relationship model, you can easily convert that to a relational database management system. That means for each entity, you are going for each entity as well as for each relationship, you are going to have tables, and using that tables, it is very easy to handle your DBMS. So if you are a good database designer, so before the actual design of the database, you should study what is happening in the enterprise, and the various methods that in your software engineering course, we'll discuss what are the things you have to do to have a very good system design, or how to study thoroughly what is happening there. A number of techniques are there. So any technique you can use, and before a good database is designed, you should have the entity relationship model of that enterprise. That means what is every detail should be there in the ER model, and once you have that ER model, a Pakka ER model, then it's very easy to design your database. Okay. That is, this is formalized by Chen in 1976. In 1976, he is the one who formalized this. In this, you have a set of entities. For example, suppose that entities represent, this is an entity, student, and suppose that this is an entity, say, department. Department is another entity, and student is, this is a relationship, that means enrolled in, student enrolled in a department. So this is a kind of relationship. Students belongs to some department or students enrolled to that department. Okay. So usually an entity is represented by a rectangle and these relationships are indicated by these diamonds. Okay. Now those are about entities and relationship. So for an entity, student, if you take this student for example, student is having a number of attributes or a number of properties are associated with the student. For example, a student is having say name, or name is an attribute of student. Then name, address is another property. Then date of birth, then address, name, address, date of birth, sex, then a number of things, for example roll number, etc. Suppose that I have identified these five properties, that means name of the student, address, date of birth, sex, roll number, and suppose that one more is there, age. Okay, so this department is having department name, say D name, then department name, say number of faculty, etc., etc. A number of attributes are associated with department also. So these are the attributes associated with student. So if you take any entity, a number of properties or attributes are associated with that. So these are all attributes. Attributes. For each attributes associated with each what attributes are associated with each entity. For each entity, attributes are associated with that. Okay. Now, each entity is composed of attributes, and each attribute can be simple or composite attributes. Yet an attribute can be simple or composite. That means, for example, this student has a name. Name is a unique one, but this name can be first name, middle name, and last name. That means you can divide this attribute into a number of segments. That means you can further divide it. That's why this name is not a simple attribute, it is a composite attribute. Address. This address is also having say street name, then pin code, a number of that means this address also you can further divide. But date of birth is a single date. Date of birth actually it's a single date. You cannot further decompose that date of birth. Sex also you cannot decompose, that is male or female. And suppose that you have a roll number, that's also you are not able to further divide it into meaningful sub components. So that is called. So this roll number, sex, date of birth, and age, these are all simple attribute, whereas address and name can further into first name, middle name, and last name. Address, you have a street name 1, street name 2, then post office, then your taluk, district, then country, etc., etc. That means address can be very composite. That means that is an attribute can be a simple attribute or a composite attribute. Okay. Now suppose that you have say mobile number. Suppose that another attribute also is there, which is mobile number. And now we are going to discuss single valued versus multi-valued attribute. What do you mean by single valued attribute? Single valued attribute means this the attribute sex. It can either male, female, or transgender. You cannot have multiple values for that attribute. Date of birth also, that is unique. Your address can be multi-valued. For example, suppose that you are residing here and you have some other house and for 6 months you are staying somewhere else. So in that case, multiple values can be there for address. Name is also unique, but mobile number. A person, there is no restriction in India for any person to have multiple phone numbers, multiple mobile numbers. So this mobile number field also can be multi-valued. That means it can be 1, 2, 3 or there is no restriction on the number of mobiles a person can carry. Number of mobile numbers a person can take. There is no limit. So in that case, mobile number also is a multi-valued attribute. That means for a same student can have multiple mobile numbers. That means it is a multi-valued attribute. Whereas this student has a unique roll number, unique sex, unique date of birth, unique name, unique age, etc. So this is called, this is single valued means it can contain only a single value. Sex of a person can either be male, female or transgender. That means single valued. Multi-valued means, for example, if they are asking your mobile number, multiple mobile numbers, that means it is a multi-valued attribute. So that is about single valued and versus multi-valued. Next is stored versus derived. See, for example, uh, here this date of birth is there and age field is there. Actually, this age can be derived from this date of birth. Okay, that means this is not a concrete one. That means this depends on this date of birth. Okay, that means this is a derived attribute from this. Here, there is no need to give age field here. This from this data, but the system can derive this field. That is why this is called derived attribute, and this is the stored attribute. Stored versus derived. That means some attributes can be derived from the other. Okay. Suppose that you are residing in Kerala, then what is your nationality? Your nationality is Indian. So that nationality can be derived from your state. Likewise, some attributes can be derived from some other attribute. That is why derived attribute and stored attribute means that does not depend on any other attributes. Okay. Now, what is a complex attribute? An attribute which is multi-valued as well as composite. Certain values are multi-valued and composite. For example, address. Address, a person can have more than one address. He may be having more than one address. At the same time, this address is a composite. Address is having a number of address can be further divided. That means it is a composite data type. That means if an attribute is both multi-valued and composite, that is called, that means this is multi-valued and composite. And if an attribute is both multi-valued and composite, that means it's a complex one. It's a complex attribute. Okay. So that's all about. So here, if you are representing this, that means this is an entity. All these entities are, so name. This is name. Entities are represented like this. This is address. This is date of birth. This is sex. This is a roll number, and this is mobile number. These are all attributes corresponding to this student, and you can connect this. That means this oval shaped boxes are represented by attributes, and here name cannot be unique one. Name cannot be a unique one. That means more than one student can have the same name. But here the unique one is roll number. A roll number of each and every student will be different, and using the roll number we can identify a particular student. In that case, we have to underline this roll number. That means that is a key value. That means in this table, if you are constructing a table like this, then definitely this roll number is the primary key. That means using that primary key, you can retrieve a particular tuple from the relation. If you are having uh, such a relationship. Okay. Now these are all attributes, and derived attributes are represented by this. This is a derived attribute. That means dotted line. Dotted line oval. That means this the age is derived from date of birth. As you can derive age from date of birth, you have to encircle this using. This is not encircling. Actually, this is an oval. This is oval. Okay, age. That means age is a derived attribute. So that is represented by dotted lines. Now, okay. So that's all about entities. These are the entities represented by a rectangle, and all the attributes of these are represented by these ovals. And suppose that this name is further divided into first name, last name, middle name and last name. This is first name, last name. Suppose that you have only first name and last name. First name and last name. We don't have any middle name. Here these are two. So you have to connect it like this. That means name is a composite attribute, and that includes first name and last name. Suppose that this address is having, say, street name 1, say street name 2, then post office, then state, etc. So that is represented like this. That means address is a composite attribute, and that composite attribute includes string 1, street line 1, street line 2, then this is post office, state, etc. That means here in this case name and address are composite attribute, whereas age, date of birth, sex, roll number and mobile number are symbol attributes. Symbol attributes. Here, what are the multi-valued attributes? Address and mobile number are multi-valued attributes, whereas all others are single-valued attributes. Here, all attributes except age are stored attributes, which age is a derived attribute. And can you say the complex attribute here? Here, address is a complex attribute.